Hey YouTube, in this video we're going to be discussing how to write the equation of a graph. Just having the graph already, which is something is kind of backwards of what we normally do, which is I give you the equation, you go find or sketch me the graph. I'm going to be giving you the graph and asking for the equation. So when we talk about a graph of an equation, first of all, it represents all of the solutions to its equation. So if we were to pick, say, some random point off of here, say this point right here, we say this is the 4, 1, and we were to plug it into its equation, we would get like a valid statement here. So there's a reason why I want to start with this situation right here. It says write the equation of this line, and I say, well, what kind of information would I need to write the equation of a line, and where do I know where this goes into the equation? Well, first of all, when you talk about the equation of a line, I suppose I would need at least one point on my line. And when we talk about lines, they're very, very boring in that they follow a slope. Like they go down 1 over 2, down 1 over 2. They rise over run for like eternity. So when we talk about the equation of a line, I think that first of all, it helps to know what the equation of a line looks like. It says y equals mx plus b, where m is like our slope value, and b is our y-intercept. Okay, so I'm going to write this two ways here. We say b, or we could say 0 goes in for x, we get b for y. Okay, so 0 comma b, but that's our y-intercept. If we could tell those two things from this graph, which by the way we can here, we say b is equal to 3, and then the slope, it looks like we went down 1, right 2, down 1, right 2. So rise over run, let's go ahead and write our rise over run. We say negative 1 over 2. We've got both the values we need. As a matter of fact, all we need to do now is just go plug this in. So you'll notice that we get this little skeleton framework of our equation where all we did was take m and b out of it. And we're actually going to plug in the values that we have adopted from the right over here. We say negative 1/2 x plus 3, and I'll clean this up a little bit here. It would look like this, negative 1/2 x plus 3. And you can see how this is clearly the equation of this graph. We say it hits at 3 and then goes down 1 over 2 for like eternity. So that being said, we're going to do trig functions in much the same way. And all of the videos you're going to see me do here involve writing the equation of sine and cosine curves. So we're going to start with this curve right here. What I want to do is this. I want to identify all known characteristics of this curve and then write the equation. Now, knowing what we know about trig functions, we are talking about equations of this form. We say a times the sine of bx plus some c value plus d value, where we've already kind of explored what these values do. So we say in the first instance here, we say at least for sine and cosine, we say the amplitude is equal to the absolute value of a. The period of the graph is equal to its normal period, which in the case of sine and cosine is 2 pi, divided b ways. Okay, so we say 2 pi over b. We could say, does it have reflection? When we answer this question, reflection yes or no, we're asking, is a less than 0? Because what we know is this: if a is less than 0, then it's reflected. Okay. Also this, we say vertical translation. So vertical shift. We're familiar that this d value out here controls vertical shift. And then we say horizontal shift is controlled by c in here, but we're going to write horizontal shift, we're going to call it phase shift. And that's just horizontal shift, shifts our graph left and right. We're going to refer to this as negative c over b. Okay, so we need to know all of these values here, but we're going to basically be able to find out from this graph these four values. We say a, so we'd have a sine blank times, or sine of, we say b times x plus some c value here plus d. Our job is going to be going through and finding out what these four values are from our graph, and some of them are really easy to do. So starting with this, we say, well, what's the amplitude of this graph? Remember, the amplitude is half of the distance from the maximum point to the minimum point, so it's half of this distance from 3 to negative 3, so 3. Or we could say it went up 3 and down 3 from like this center line. So we say the amplitude. Let me rewrite that there. We say amplitude is equal to 3. So we'd say then a itself must be 3. Now when I look at this, I say, well, what kind of a curve is this? So it looks to me like we've got a sine curve, up, down, up, okay? So this is a sine curve. Sines typically go, starting on the ground up to its maximum and then down to its minimum and back. But is this one reflected? And it's not reflected. So we could say a is positive. We want to make sure that we write this down. So we say it's a positive 3. How about b? Now b deals with the period here. We know that the normal period is equal to 2 pi over b. In this case, we'll say, well, what is the period of this graph equal to? We can say, well, from 0 out to 2 pi, the period is 2 pi. So we're going to write period as 2 pi, but here's what I also know. I know that the period is equal to 2 pi over b. So what we're going to do is we're going to set this equal to 2 pi over b. As a matter of fact, we'll just say this in general. All the time, you take what the period is and you set it equal to 2 pi over b, and we'll solve for b. Now, I want you to notice this. If I put this over 1, then b and 1 are clearly the same thing. But I'm going to write this down also. I'm going to say then b equals 1. So far, we've got an a equals 3, b equals 1. You know, in terms of finding c, was this shifted left or right at all? No. So we'd say no horizontal translation. Then we get 0 for our horizontal shift. So it didn't shift up or down at all. So we say our d value is 0. So the equation of this graph, this is just our normal sine curve where we're saying we have an a value of 3. So y equals a times sine of bx. So we say what is b? We determine b is 1. So we'd say 1x, 1 times x, plus a c value of 0 plus a d value of 0. So you can see that this really just simplifies down into 3 sine of x. And this is really just our sine curve that has an amplitude of 3. So that's one example of writing the equation from a graph.